Welcome to Complexity Made Simple. My name is Paul Allen and the subject of today's video newsletter, well, today what we're going to talk about is we're going to talk about type 1 and type 2 errors in hypothesis testing. I've had a request from one of my subscribers who asked me to cover this specifically. It's not covered in any of my other videos, so that's what we're going to be talking about today. Just before we get on to that, just a reminder, please click below and subscribe. If you like the content of the videos, please go and buy my book from lulu.com. It's called Drink Tea and Read the Paper. It contains all the material that's in my videos. And if you have a specific need, especially if you're watching this and you're thinking about hypothesis testing, design of experiments is where hypothesis testing should be used the most in your area of influence. Design of experiments for 21st century engineers, my latest book. Both of these are available from lulu.com. Go and buy them now. Okay, let's get on to this subject. We're going to be talking about hypothesis testing. We're going to be talking about type 1 and type 2 errors. So that's what I've been asked to describe. So, first of all, we just ought to cover, why do you do a hypothesis test? Okay, so hypothesis tests. Now essentially, doesn't matter what your role is, if you're trying to understand your process and you're trying to take new decisions, you're trying to come up with new settings, new ways of running your process, the hypothesis test is an absolute must-have tool. And here's why. Imagine you take two samples from your process. The two samples are from an identical process. You've made no change, no improvement. So this could be something simple. A doctor who is treating cancer patients. They are treating prostate cancer, let's say. They take 100 patients in sample A and 100 patients in sample B. Both groups are given an identical treatment. There is no difference between them. But of course, when you look at the results, what will you see? Well, in terms of their ability to survive, you will see a slight difference. You will see a difference. Now, the difference could be slight, could be a lot bigger, but you haven't given them any different treatment. Now, if I took a third group, what would I see from the third group? I'd see a different number again. Then a fourth group, a different number again. So it doesn't matter, even when your process is stable and you're not changing anything, every time you take a sample, you'll always see some kind of new result. It'll always be slightly different. So what does the hypothesis test do? Well, the hypothesis test is there to help you when you do make a change. So the doctor now, this was two samples with no change. The doctor now decides that they're going to give them some additional drug. So we take sample A, 100 patients with the old treatment, 100 patients with a new treatment and a new drug. What will he see? Well, the doctor, of course, will see two different results. The question is that because of my new treatment? Or is that because two samples are always different? So we have this idea now of we have made a change. We've made a change to the process. And the question is, the difference that I'm seeing, did I do that or was it just luck? And that's what the hypothesis test is telling you. It's telling you what's the chance If you conclude that you created that change, the hypothesis test is going to tell you what's the chance you're wrong, essentially. You're going to get a p-value, a probability value. Now, of course, there's two decisions you could make. You could make a decision that says, so you've got your decisions. The one decision could be, you reject the change. The other one is you accept the change. And of course, when you're making those decisions, the hypothesis test can make two types of mistake. And this is where the type 1 and the type 2 come from. The type 1 mistake is known as an overreaction. And the overreaction is you conclude that you have changed the process when you haven't. You've overreacted. The process hasn't moved, the process hasn't been affected by your new, in a manufacturing situation, a new supplier, a new setting, a new way of training the operator. The process hasn't been changed by your new procedure, but you assume that it has. That's known as a type 1 error, and it is known as an overreaction. Now, the overreaction in hypothesis testing is minimized by your probability value. How certain do you want to be you haven't made a mistake before you judge that you accept the change? And usually the probability value goes down to 0.5, which in other words, there is just a 5% chance you're wrong if you conclude that the shift you're seeing was because of your new treatment, your new supplier, your new setting, your new training procedure. So we like to let the probability value go very small before we conclude that a change is present. But of course, the other type of mistake is type 2. Type 2 is that you underreact. So type 2 is there is really a change, there's really been an effect to the result, but you don't accept that. You think that the process is still stable, the process has been unaffected by your new way of working. Now, the type 2 error, which is known as underreaction, this is controlled by sample size. So typically, if you can't be bothered to collect enough data points, so I mentioned that with the cancer treatment, it was 100 versus 100 people. Now, for cancer treatment, that wouldn't be enough. We would want to go at least 1,000 versus 1,000 and possibly slightly more than that. So the sample size is very important because the sample size helps us to clarify that we can see a signal if a signal is truly present. So this is why sample size calculations, so it's different depending on each situation, but you should do a sample size calc before you start. You should take a correct sample size. That will help you to minimize type 2 errors. You should only accept change if your p-value goes below 0.5. 0.5 minimizes the type 1 error. Sample size minimizes the type 2 error. And that essentially is type 1 and type 2 mistakes in hypothesis testing. Now, personally, I don't make one factor changes in my process work. So I would very rarely use this as an individual tool to take out of the box and use for a single process change. Normally what I'm doing, as I mentioned earlier, I'm doing designed experiments. When I do a designed experiment, they are full of hypothesis tests. I rely on hypothesis tests to prove true process knowledge. They say, by the way, with engineers, we tend to overreact most of the time. So we think we've made a change all the time when we go and twiddle the dials, and we really haven't. DOE is full of hypothesis testing. That's why it's the fastest way to get new knowledge. So if you're going to use hypothesis testing, you really should go and look up design of experiments, because as an engineer, this is the fastest way to get new knowledge. It's the fastest way to make more money. Use hypothesis testing, use DOEs, make more money.